Hello students, in today's class we are going to discuss few questions from mean value theorem. There are two mean value theorems according to CBSE portion. The one is Rolle's theorem, the other one is Lagrange's mean value theorem. So in this class we will discuss few questions based on Rolle's theorem. This is also one of the mean value theorem. Okay. The function f of x equal to x minus a the whole cube, x minus b the whole power 4 in the closed interval a comma b. So let us start taking the question first. X minus a whole power 3 x minus b whole power 4 and is a polynomial function. So remember, polynomial function is always continuous in its entire domain. The given domain, and we have to test the continuity of the function in the closed interval a comma b. Because of polynomial function, f of x is continuous for all x belongs to the closed interval a comma b. And every polynomial function, every continuous polynomial function is differentiable in its corresponding open interval. So if this of x exists for all x belongs to the open interval a comma b, then you can find f dash of x applying product rule between these two factors, 3 times x minus a the whole square and x minus b the whole power 4 plus and x minus a the whole cube derivative of second factor 4 times x minus b the whole cube, taking common factor x minus a the whole square and x minus b whole cube into 3 times x minus b plus 4 times x minus a. Then f dash of x equal to x minus a the whole square and x minus b the whole cube then 3x plus 4x 7x minus 3b and minus 4a. Okay, this is f dash of x 4a. Then we have to test f of a x equal to a 0 and f of b x equal to b 0 into x minus a whole cube 0, and this implies f of a equal to f of b. Then by Rolle's theorem, there must exist a mean value x equal to c belongs to interval a comma b such that f dash of c equal to 0. So if we take f dash of c equal to 0, then c minus a the whole square and the c minus b the whole cube into 7c minus 3b minus 4a is equal to 0. Then c minus a is not equal to 0, c minus b also is not equal to 0. Then 7c minus 3b minus 4a must be 0. So as c minus a not equal to 0, c minus b not equal to 0, because c belongs to a comma b open interval, so definitely c is not equal to a. C should be more than a and c should be less than a. The first two factor non-zero factor, then the third factor 7c minus 3b minus 4a must be 0. This implies c equal to 3b plus 4a, so divided by 7. So this is nothing but if we take the interval a comma b, the point c lies between a comma b, or the point divides the segment AB, or in the interval AB in the ratio of and 3:4, 3b plus 4a by 7. According to section formula, c should be one of the mean values of the interval open interval a comma b. So definitely this belongs to the open interval a comma b. So when c equal to 3b plus 4a divided by 7, the function is verified or applicable for the statement of Rolle's theorems. Okay, this is the value of c. So dear student, keep watching this. We will discuss one more similar problem. Next question. Verify Rolle's theorem for the function f of x equal to log of x square plus 2 minus log 3 in the open closed interval minus 1 comma 1. So f of x is log of x square plus 2 minus log 3. So log of x square plus 2 is continuous function. The continuous function with plus or minus any constant, again continuous function. So is a logarithmic function. Then f of x is continuous for all x belongs to the closed interval minus 1 to 1, and we will find f dash of x first. 1 by x square plus 2 by chain rule 2x. Then f dash of x equal to 2x by x square plus 2. So for all values of x from the open interval minus 1 to 1, x square plus 2 is going to be real number, and f dash of x is real numbers belongs to, or for all x belongs to open interval minus 1 comma 1, and therefore f dash of x exists for all x belongs to the open interval minus 1 comma 1. Okay. Now we will try to find f of a and f of b. F of a, f of minus 1 and log of 1 square 1 plus 2 3, log 3 minus log 3 equal to 0, and f of b, f of plus 1, again log 3 minus log 3 equal to 0. Therefore f of minus 1 and f of 1 are equal. So according to Rolle's theorem, so there must exist at least one mean value, x equal to c belongs to the open interval minus 1 comma 1, such that f dash of c equal to 0. So f dash of c, we can use f dash of x 2c by c square plus 2, that is 2c upon c square plus 2 is equal to 0 after cross multiplication, and C equal to 0 belongs to the open interval minus 1 comma 1. So the mean value C equal to 0 of the open interval minus 1 comma 1. The function is verified for Rolle's theorem statement. Therefore, a Rolle's theorem is verified when C equal to 0. So dear student, keep watching this. We will discuss one more similar question from Rolle's theorem. The next question, verify Rolle's theorem for f of x is equal to cos 2 of x minus pi by 4 for all x belongs to the closed interval 0 comma pi by 2. So let us start with the question, f of x and cos 2 of x minus pi by 4. So is a trigonometric function. The given trigonometric function with the period pi. So with the period pi, so 0 to pi by 2 in the given closed interval, f of x is continuous. So f of x is continuous for all x belongs to the closed interval 0 comma pi by 2. Let us find first f dash of x. Derivative of this minus 2 sine 2 of x minus pi by 4. So this is real numbers for all x belongs to the open interval 0 comma pi by 2. So therefore we can say f dash of x exists for all x belongs to the open interval 0 comma pi by 2. And f of a, that is f of 0, and cos 2 into 0 minus pi by 4, that is cos minus pi by 2 is equal to 0, and f of b, f of pi by 2 then is equal to cos 2 of pi by 2 minus pi by 4, again cos pi by 2 equal to 0. So this implies f of 0 and f of pi by 2 both are equal. So by Rolle's theorem, there must exist a mean value x equal to c of the open interval 0 comma pi by 2 such that f dash of c equal to 0, and this implies f dash at minus 2 sine of 2 into x minus, that is c minus pi by 4 equal to 0, and this implies sine 2c minus sine pi by 2 equal to 0. So this implies 2c minus pi by 2 must be 0, then 2c equal to pi by 2, and this implies c equal to pi by 4 belongs to the open interval 0 comma pi by 2. So when c equal to pi by 4, the function is verified for Rolle's theorem. So the function is verified for Rolle's theorems. Now Rolle's theorem statement is verified when c equal to pi by 4. This is one of the mean values of the open interval 0, pi by 2. Keep watching this, we will discuss one more question. So dear student, we will discuss one more question from Rolle's theorem. The function is sin x minus sin 2x for all x belongs to the closed interval 0, pi. So sin x continuous function, sin 2x continuous function. So the linear combination of two continuous function is always continuous function. So we can conclude f of x equal to sin x minus sin 2x is a continuous function. For all x belongs to the closed interval 0, pi. Then we will find f dash of x, then confirm whether it is differentiable or not in the open interval 0, pi. So derivative of sin x cos x minus 2 and cos 2x. So this can be written as either sine function or cos function. So it is always real number for all x belongs to the open interval 0, pi. So this shows that f dash of x exists for all x belongs to the open interval 0, pi. Now what is f of a? That is f of 0, sin 0 minus sin 2 times 0 is equal to 0, and f of b, f of pi, that is sin pi minus sin 2 pi, 0 minus 0 equal to 0. This shows that f of 0 and f of pi equal. So by Rolle's theorem, so there must exist a mean value x equal to c of the open interval 0, pi such that f dash of c equal to 0. So f dash of c cos c minus 2 cos 2c equal to 0. So this implies, and cos c minus 2 cos square c minus 1 equal to 0, minus 4 cos square c plus cos c plus 2 equal to 0, then 4 cos square c minus cos c minus 2 equal to 0. Okay. So applying quadratic formula on this, we can get cos c equal to minus b 1 and plus or minus root of b square 1 and 4 into 4 16 into 32 divided by 8. Then cos c equal to 1 plus or minus root of 33 by 8. So a root of 33 approximately 6.7 by 8 and 1 minus, so both belongs to the interval minus 1 to plus 1. Okay, is more than minus 1 and less than plus 1. So this implies c equal to cos inverse of 1 plus or minus root of 33 by 8 is belongs to interval 0, pi. So when c equal to cos inverse of 1 plus or minus root of 33 by 8, the given function f of x equal to sin x minus sin 2x is verified for Rolle's theorem statement. So dear student, keep watching this. So my dear student, my humble